In 1982, scientists set sail aboard a ship with a giant drill stuck on the back of it. Their goal? To extract columns of seafloor and let layers of sediment tell a geologic bedtime story. But nestled within a layer around 66 million years old, they found something completely unexpected. They found a fossil. Just 2.5 millimeters across, but it was not one of the last dinosaurs or any other life forms wiped out when a massive space rock hit the Earth. It was a fossil of a rock that came from space. It could be a fragment of that deadly meteorite, and as one of the first fossilized meteorites ever discovered, it has shown us a new way to learn about our planet's past. Now I know what you're thinking, because it's what I was thinking. How can a rock become a fossil? Aren't fossils things that were once alive and became rocks? Well, that is one definition, but fossil meteorites go through basically the same process as dinosaur bones. After getting stuck somewhere wet, like at the bottom of the ocean, they get buried under layer after layer of sediment. Then water can wear away and react with the meteorite to remove some, if not all, of the original primary minerals and deposit new secondary minerals in their place. Now, if you weren't a rock at the beginning of that process, congratulations, you are a rock now. And if you started out as a space rock, well, now you might seem indistinguishable from an Earth rock. When scientists dig up a bone-shaped rock, it's a bit obvious that it once belonged to a living thing. But how can they tell a rock-shaped rock is a fossil that came from outer space? Well, it turns out there are several kinds of clues. First off, there are some primary minerals that are both only found in meteorites, and the fossilization process has a really hard time clearing out. Scientists tend to hunt for certain kinds of spinel in particular. And if you started off as an iron meteorite, your extraterrestrial origins can be revealed by a unique texture called a Widmanstätten pattern. This pattern is created by cooling iron exceptionally slowly in the core of an ancient planet, and while the iron in fossil meteorites can be pretty badly rusted, this telltale pattern is sometimes still visible. But to test that fragment of rock pulled up from the seafloor, the one that could have killed the non-avian dinosaurs, scientists compared the amount of individual elements against known space and Earth rocks. According to their measurements, the amount of chromium, iron, and iridium were very close to modern meteorite samples. Meanwhile, it had a lot less cobalt and nickel, but about 1,000 times more gold than they would expect in a meteorite. These were all probably changes that occurred during the fossilization process. So we can be pretty sure that this rock came from space, and we know roughly when it arrived on Earth, but we can't say for certain it was part of the rock that caused a mass extinction. It could have come from a much smaller impactor and just happened to hit our planet around the same time. To draw any real conclusions, we'll have to find more fragments with a similar age and composition, and preferably in completely different locations. That would indicate that an extreme impact had flung them far apart. But finding fossil meteorites is a lot easier said than done. When we say fossil meteorites are rare, we mean really rare. In fact, in the early 20th century, some geologists debated if they even existed. They thought meteorites were only a recent thing because they just hadn't found any that fell millions of years ago. The first confirmed fossil meteorite was found in 1952, but it wasn't until 1979 that scientists actually took a closer look and figured out what it was. As of 2017, we have found 115 fossil meteorites, and the majority have come from a single place in Sweden, the Thorsberg limestone quarry. The limestone here is a treasure trove of fossil meteorites because it formed unusually slowly, beginning as an ocean floor over 470 million years ago. Layers of sediment built up about 10 times slower than usual, only a few millimeters every 1,000 years. That meant that there was more time for meteorites to fall into the ocean and get caught in the growing limestone layers. But that doesn't just make Thorsberg Quarry great for finding cool, unusual rocks. Together, these fossil meteorites tell the story of a massive collision that took place in our solar system's asteroid belt between Mars and Jupiter roughly 470 million years ago. And by massive, I mean the largest asteroid belt crash that we know of from the past 3 billion years. Some of that debris quickly made its way to Earth, causing a storm of space rocks to rain down on the planet over 200 million years before the dinosaurs showed up. Animal life on Earth was still sticking to the oceans at that point, including an ocean that would become a Swedish limestone quarry one day. But that space rock storm actually hasn't stopped yet. Around a quarter of the meteorites falling today have the same composition, so we're pretty sure they are the remnants of that event. And based on the number of fossil meteorites we've found so far, the impact rates started off around 100 times higher. In fact, some scientists believe this ancient barrage could actually have given evolution a helping hand. According to the fossil record, we know there was a big acceleration in the evolution of marine life right around that time. It's called the Great Ordovician Biodiversification Event. So one hypothesis is that after this massive outer space collision, the resulting space dust could have changed Earth's climate by blocking the sun, or a surge in impacts could have caused some species to go extinct a bit more directly. This could have opened up space in the ancient ocean ecosystem for new creatures to emerge. Let nature test out a bunch of new evolutionary forms and fill some empty niches. Not everyone agrees about this, though. One 2017 study suggests that the time between the barrage of impacts and the burst of evolution isn't close enough for the two events to be related, so science is still working out the kinks here. Now, because of the wealth of scientific knowledge that fossil meteorites can bring, Thorsberg's quarry workers are trained to identify potential fossils. They've been methodically searching in their worksite since 1995. But that's not all. One scientist even made it a habit of crawling around in public buildings with limestone floors in Sweden, searching for ones that slipped out of the quarry unnoticed. In years of searching, he claims to have found only one, embedded in the floor beneath the staircase of a train station. He will not, however, tell anyone exactly where it is. So while your chances of finding a fossil meteorite might be low, you might want to keep an eye out the next time you're walking through a limestone building, especially if you're Swedish.